Sir, you just run this glorious race. How do you feel as of right now?
Man, I feel tired, but I feel good. I feel like I could ride this high of serotonin for days.
Wait, serotonin? Wait, serotonin? I'm the expert.
Yeah, I just have a couple questions. Okay. So, about this feel good chemical, do you know anything about it?
Oh yeah. Okay, so serotonin is a crucial factor when it comes to muscle movement, not just for mood. It acts more like a delivery carrier.
Oh, so it's like an Amazon delivery driver in my body.
Well, yeah, you could say that. So basically, your brain sends signals through the neurotransmitter when you want muscles to contract, and serotonin manages the process to make sure that everything is running smoothly. So without serotonin, the signals can be spread across your whole body, which can be too strong or too weak, and even misfiring at the wrong place. And with too little serotonin, you experience muscle stiffness like Parkinson's disease, while too much serotonin leads to abnormal muscle twitching and movement.
Huh. Okay. So, do you know where this serotonin came from?
So, that's a cool part about serotonin. So, it was first discovered by an Italian scientist named Vittorio Erzheimer in 1935, who found it in the gut and named it enteramin. It wasn't until in the late 1940s for American researchers to isolate serotonin from blood serum and named it serotonin.
Huh. That's interesting. And how exactly did they come up with the name?
Well, it's a combination of serum and tonic, referring to its role in blood vessel tone regulation because it was everything known back then.
Can you tell more about how it works?
Well, I'm just an enthusiast, maybe, so you should ask an expert.
So, how does serotonin work, and what are its functions? Serotonin, the feel good molecule, is affecting everyone in this gym in one way or another. For athletes, it helps them stay at the top of the game. Now, serotonin has many functions, but two of its most important are its roles in mood regulation and sleep regulation. So, how does serotonin help athletes regulate their mood? At normal levels of serotonin, athletes will feel calmer, more focused, happier, and emotionally stable. This could help them stay at the top of the game and play better. However, low levels have been associated with depression, anxiety, irritability, and more, which could lead to worse play. Ooh. Now, research has also shown that there are specific serotonin receptors associated with specific behaviors and emotions. This means that your serotonin levels can help you or can make you react differently in situations you find yourself in. Specifically, in a mouse model in 2021, they knocked out serotonin receptor number 4. Now, this receptor is highly expressed throughout the brain, but namely within the hippocampus. So, in this mouse model, they knocked out this receptor and found that these mice exhibited an anxiety-like phenotype compared to wild-type mice, or mice without the knockout. This showed that receptor played a role in regulating that mood. Now, you'll hear a lot about athletes promoting sleep and how it makes their play better and how beneficial it is. But did you know that serotonin is also a regulator of sleep? So how does serotonin regulate sleep? Well, it promotes wakefulness, so that means it keeps you awake at the right time. This was determined through more mouse models where they knocked out serotonin receptor 2A and 2C, and they found that these mice exhibited more levels of wakefulness compared to wild type. So now we know that serotonin is good at keeping you awake, it's good at regulating your mood, but what are some of its other functions? Serotonin has also played a role in your learning, memory, blood clotting, even cardiovascular function. So it is a super important molecule. So now that we know some of the functions of serotonin at normal levels, what does it look like when their levels are irregular?
At irregular levels, serotonin has been linked to several functions of the body being disrupted both physically and psychologically. Psychologically, low levels of serotonin can lead to mental health conditions like depression or OCD being formed. Mood changes have also been observed, and serotonin plays a key role in controlling one's impulses, which a lack of may lead to falling prey for gambling, let's say. Physically, low levels of serotonin have been associated with digestive problems, sleep problems, and other physical conditions like diabetes or obesity. Irregular levels of serotonin may be caused by a multitude of factors, including chronic stress, diet, lack of sunlight, drugs, or lack of receptors. There are several ways to increase serotonin levels within the body. A diet which includes tryptophan-rich foods, like these right here, are a good way. Other ways are several minutes of sunlight for that vitamin D, aerobic exercises, and stress management all aid in the production and release of serotonin. In certain cases, medications like SSRIs may be prescribed to treat mental health conditions. However, I wonder how they work.
Great question. How do SSRIs work? Let's first go over how serotonin functions in the brain normally. When an action potential is sent down the presynaptic cell, it causes calcium channels to open, allowing calcium ions to flow into the cell. This causes little packets of serotonin, called vesicles, to bind to the cell membrane, which allows serotonin to flood into the area between the synaptic cells, called the synaptic cleft. This serotonin then binds to active sites on the postsynaptic cell, opening ion channels, which allow ions to flow into the postsynaptic cell, continuing the action potential. Finally, serotonin molecules are then brought back into the presynaptic cell in a process called reuptake. So what happens when we add SSRIs into the equation? SSRIs come in and physically block the protein channels that bring serotonin back into the presynaptic cell. This allows the serotonin to remain in the synaptic cleft, where it can continue to bind to these active sites, which allows ions to continue to flow into the postsynaptic cell, which allows action potentials to continue, increasing the effectiveness of the serotonin currently in your brain. So did everybody get that?